Hello everyone, we're going to be going over some normal distribution for our Algebra 2 trig class today. This is really nice because the entire diagram that you need to know is actually given to you on your reference sheet. So you don't have to memorize very much, you just need to know how to use it. So, some data fits into a normal distribution, meaning it will have the properties in this diagram below. It fits into the normal curve. So you'll see a lot of information on here. We're going to go through it real quick, explain what each part of this diagram means, so that you will be able to solve problems like a champion. So in the diagram here, you'll notice that there is a 0 right in the middle here, this line down the center. In the diagram, 0 represents the mean. That's the average, straight down the center. The other numbers going from the left to the left and the right. So 0 is right in the center here, and then you have 0.5 above, 1 above, 1.5 above, and going to the negatives the other way. Negative 0.5, negative 1, negative 1.5. Those are actually how many standard deviations away from the mean a number would be. Also, since 50% of the data would be above and 50% would be below, that means that 0 also represents the median number, the very middle of the data. And it has the highest percentage there. It's the highest part of the diagram, so it also has the most values, meaning it's the mode as well. So that 0 represents the mean, median, and mode in what we're talking about right now. Data is said to be normally distributed, or standardized is another word for it, if it is made to fit into this normal curve. So it takes the properties of this curve, which again is on your reference sheet, so you don't have to memorize this. If you add up the percentages, you'll see approximately. I'm going to switch over so I can do some drawing here. So you'll notice that 68% of the distribution is within one standard deviation. So from negative 1 to positive 1, if you added up each of those numbers, 15, 19.1, 19.1, and 15, that gives you approximately 68%. You'll also notice that within two standard deviations, so going from negative 2 all the way up to positive 2, if you add all those up, it's 95%. 4.4, 9.2, 15, 19.1, 19.1, 15, 9.2, and 4.4. If you add all those, it gives you about 95%. And if you want to go 3 standard deviations away, so even further, so we're talking about from this end all the way down to the other end, if you add all those up, it ends up to be 99.8% of the data is within 3 standard deviations. Anything more than that, and it starts to get 99.999%. So pretty much any number you can pick from a set of data is going to be within 3 standard deviations of the average. There's a little diagram on the side there showing you that the X bar, the average, is the center, and then you're talking about 1 or 2 or 3 above or below. So you can look at that on your own. We can add percentiles in now. So a percentile is the percent of scores at or below a certain value. So if I'm asking where's the 50th percentile, well, 50% of the information is at or below the average X bar there. So we're going to talk about that a little bit. And we're actually going to add some numbers into our diagram here. So the first percentile that we're going to add in is going to be at negative 2. So this bar right here. And that is going to be the 2.3 percentile. So 2.3% of the data is at or below that. If you go up to negative 1, your percentile changes to 15.9, or about 16. The average, as we said, the mean, is the 50th percentile. 1 above is the 84.1 percentile, and 2 above is going to be the 97.7 percentile. So you'll see exactly how that fits in just a second. So we're going to look at an example quickly here. Scores on the PSAT range from 20 to 80 for a certain population of students, and the mean is 52. So the very first thing I would do if I was you is I would draw a little curve here. You don't have to put all the lines in it, but just draw the standard curve. So draw this part here. And then I would say, okay, they told me that the mean is 52. So 52 is going to be my center line right there. 52 is right down the middle. After that, I would say, okay, the standard deviation is 9. So that means if I go 1 above, that's going to be 52 plus 9, which is 61. And if I go up to 2, I'm going to add another 9 on it. So that's 61 plus 9 is 70. If I go the other way, from 52, I'm going to subtract 9. And I'll end up at 41. Sorry, not 41, 43. And if I subtract another 9 to get 2 standard deviations below, I would end up at 34. And they say which score is within the 65th percentile. So what you can do is start adding up each of these numbers. So you're going to take 0.1, 0.5, 1.7, 4.4, 9.2, 15.0, 19.1, 19.1, and you're going to keep going and adding these numbers up until you end up with something that is at or above the 65th percentile. So if you add up all the ones I have highlighted in blue here, all the way up to right here, you'll find out that that actually goes up to 67.7. So if you're looking for a score, your choices are 49, 56, 64, 65. So which one of these ends up in, oops, I went one too far with my blue there. Which one of those ends up in this range right here, in between here, so from 52 to 61. The only choice that's between 52 and 61 is 56, choice 2. Looking at the next one, which one of these scores can be expected to occur less than 3% of the time? Again, you want to look at your percentiles here and figure out which one of these lies within a place where there is less than 3%. So we knew that the middle again was 52, and our numbers were 61 and 70. So which one of these, oh, going the other way, 43 and remember to wear your ugly Christmas sweaters tomorrow. For Mr. Chimay's crew. If you're in my crew, don't wear ugly sweaters. We don't like ugly things. They're bad. So we're looking for something that is 3% of the time. So if you notice, 3% actually ends up either in this small section right here or in this small section up here. So you need something that's below 34 or something that's above 70. And the only possible choice there is going to be 71. There's nothing else that falls below 34 or above 70. What I'd like you to do for examples 2 and 3 is not necessarily answer the questions. But what I would like you to do for each one of these is look at and sketch a standard deviation curve, and you're going to need to draw the actual curve, and then I want you to draw the mean, and I want you to find what's 1, 2, and 3 standard deviations above, 1, 2, and 3 standard deviations below. Okay? So they tell you the information in this problem that you're going to need to know to do that. We will go over that as soon as you get into class tomorrow. For question 3, very similar. Again, draw your curve and then find your mean, which you should be able to do. They give you these two numbers. You should be able to find the mean. And then find what's 1, 2, and 3 above, what's 1, 2, and 3 below. And we will go over both of those first thing when you get into class tomorrow. So, to sum this up, standard deviation, you don't have to memorize the curve, but you have to know what all the numbers mean. They will give you all the percentages. They will give you the numbers on the bottom for the standard deviations, but you need to know how to interpret that in terms of the problems. I know it sounds a little complicated, but really it's just a whole bunch of adding and subtracting when you get down to it. We'll practice this some more tomorrow. Have a wonderful evening. I'll see you mañana.